Hi everyone, welcome back to this new video of our backend development series. I am Siddharth and today we are going to learn about data modeling. Now, data modeling is a very important part of designing your backend project. In this process or in this phase of data modeling, we actually decide the purpose and objective of our database and how we should define the data of what kind of data is going to be stored in our database. So this is a part of the database engineers, but since you are a developer, backend developer, it is also expected that you have some knowledge about data modeling. So I am going to not restrict this video from a language point of view. It can be done in any backend language, since all the backend language majorly available, they all allow backend connectivity to some of the other backend apps, database apps, like the MongoDB, Postgre, MySQL, like that. So I will not restrict the language barrier of this video, but I'm giving you the idea based on which you can design any backend systems in future for production. So I'm going to show you few tools which are used inside production for designing our database, and I hope you will like it. So let's directly go to our browser and we will see what are the tools which are used in production for designing and modeling our database. So let's go to the screen. So the first thing which I would like to show you is Moon Modeler. So Moon Modeler is a thing which is used in production for designing the database for NoSQL like databases. As you can see, we have a diagram created for MongoDB and it will automatically generate the code for you. That's the lucky part of it. So if you enter the order, this is the customer ID, date, total value. So like this, you can design and accustom yourself to the design of a database using the Moon Modeler. Right. The next thing which we will use actually in our project is eraser.io. The reason for not using Moon Modeler because it is a paid version, but since we are learning it from the course point of view, we will use the eraser.io. This is also a very friendly tools for developers for designing the database, and this also has the features of generating the code, but we will not generate the code at this point of view because I'm just want to give the approach to you for how to approach the designing of the database. So without further delay, let's get started. So suppose let's take an example. We are designing a e-commerce app. So we are designing the database design of an e-commerce app. So let us write over here e-commerce. So majorly when you design an e-commerce project, the first thing which comes to your mind is about the products. So every product, this is the product. Every product will have few properties. So every product which you have will have a product ID, right? Obviously, which will uniquely identify a product from the other products. Okay, it will have a product name, right? Next thing is that it will have the category, in which category your product belongs, right? After that, you will have the name of the seller who is selling the product. After that, you will have the count of the number of entities of that particular product is present in your system, that is your remaining items, because you cannot serve unlimited items on e-commerce platform, right? There will be certain limits of a certain product which will be available. Now obviously the pricing of the product both in INR, USD, that's up to you, right? After this, you will have the space for introducing the customer review, right? Now the important part lies around here, which says that this is the product ID, this is the place where you write or define an ID which will differentiate your product from the other. But so what will be the type of the product ID? The type of the product ID in this place will be of object ID type, which is automatically generated by any NoSQL database service which is available. So you can write it as object ID. So you cannot generate it in yourself. It will be automatically generated by the database provider you are taking. I will show you everything. So product name can be of data type string, right? Next we have the category. The category will be of type string only, or you can use enums, which will have a category of string. So enums, and inside the enums you will have the string types. So enums, we have studied in C++ that there are a specialized set of strings, and under this category only our products can be listed. After the category we have the seller name. So seller name is also going to be a string, but it will be quite obvious that if you think the seller name would be a string at this point of time, because you have not started the backend journey actually. So I have faced an issue where both the sellers have the same name, so that created an issue. So for resolving that issue, we provide the seller ID in this place. So since it is seller ID, so it will be object ID as well, which will differentiate the seller from one another, because seller ID is always unique. So seller ID, right? So remaining items will be number, obviously, right? The next thing is the price. So the price can be your decimal type, so we will write double type or say numbers only. Okay, since the JavaScript do not have the number provision, so we will write numbers only. Okay, customer review. So customer review will be an array. Why? Because customer review can be many, and many customers will have their own type of review. So this will be an array of objects. Now what will be the objects containing? The objects will contain the customer name or say ID, and his comments. So it will be the array of reviews, which will have the customer ID and comments as an object in the entity. So this is actually a bare minimum outline of how a product schema for a e-commerce platform will look. Now this can be expanded to many ways about deciding the delivery date, the amount of tax, and the offers. So this can be designed in many ways. So I'm just giving you an idea of how the e-commerce project is actually looking like from the backend point of view. Okay, so let's put this aside. So this is our product schema. So let's write it over here, product schema. Product. Now, since this is a product schema, then it is also important that we should also design the schema for the person or the users who are buying it, that is the customers. So let's define another schema for customers. So let us write it over here, and here we will write the schema for the customers. Customer schema. Now schema directly means that the type of the data and what will be the constituents of this particular collection. Okay, so once you define the customer schema, we will now write point wise what are the things which are expected to be present inside this. So the first thing which is very important, which is the customer name or the customer ID, first place. So this will also be of object ID type, customer ID. Now this will also be of object ID type, since many customers can have the same identity of name, so object ID, right? Next comes his name, customer name. Okay, this is going to be of string type, right? The next thing, which is the customer contact details, so it may be his customer email ID. Okay, this will be also of string type. The next will be customer contact details, that is phone number. Let us write phone number. So phone number will be of again string type. It will be number types, but some places you will find that it is of string type. Why? Because every phone number starts with a +91, that is a country code, but since plus is a character, so it cannot be stored inside a number. So at that point of time you have to take some things into consideration, whether you are going to allow that plus or not, or you have to select the country code from another type of data. So this was his contact details. Next comes his customer's address. Okay, so it will be of string type only. After this, we have the details of the customer. Apart from this, we will now have the cart items. That means the items which are in their cart. So cart. Now cart items can be many items there can be present inside the cart. So this will be an array. Now what will be the constituents of this array? This array will also consist of products object. Now inside this object we will place nothing, we will just place this product ID which we generated over here. So once I have the product ID, with that product ID I can obviously find out what is the name of the product, what is the category of the product, what is the seller ID, this in this way. So this is about the cart. Well enough. Now once I have the cart of the user, the next thing is obvious, which is my orders or customers orders. That is how many orders the customers have made today. Okay, so how many orders the customers have made today, this is also going to be an array, because at a point of time a customer can have multiple orders. So the orders will also be of product ID type, because he will order products obviously, right? Product ID. Okay, now also he will make some sort of reviews here in the product schema. So for that you have to mention here customers review, about which products he has made a review. Now see, you can expand this database to atrocities, right? But let's limit this customer product. Okay, let's write over here product. So let's limit this customer schema up to this much. So this was about the design of database for an e-commerce app. This is the bare minimum design, right? So this is the customer, this is the product. Now in this way you have to design the seller also, you have to design the delivery guy also in this way, so that your system becomes very robust and very stable. So I'm giving you an assignment to you to design the schema of the user the delivery guy and the seller. So the seller will have the seller ID, seller name, the amount, numbers of product he has put into the repository, like that. So this was the design of an e-commerce platform. Now next, let's have a look and design the database design of another thing, which is a to-do list app, which we are going to make in future in this series only. So the to-do list app is nothing, it will keep a collection of the to-dos for a particular user. So since it is keeping a collection of to-dos, the to-dos will have a schema also, and apart from this it will also keep a collection of the users who have their to-dos inside the application. Now, so since it is going to be a to-do list app, so this will be my to-do schema, and this is going to be, let's write it over here, to-do schema. Remember that this is not from the JavaScript point of view, this can be done in any backend language which you have learned. Okay, so I'm not limiting or restricting the language from this point of view. And this is going to be the user schema, right? So in the to-do schema, what will identify a particular to-do from one another? So it will be its to-do ID. Very well enough. Just a minute. It's disturbing. All right. So the first thing which will distinguish a to-do from another, which is the to-do ID, right? That is the object ID type. Next, the to-do title. To-do title. You will always need a to-do title for your remembering. Title. That is a string type. String. All right. Next, the description of the to-do, about what is inside the to-do. Okay. To-do description. Okay. This will be a string type as well. Next, it will be the time before which you want to complete the to-do. So it will be a deadline. So here we will introduce a new data type, which is a date data type. Okay, so it will be a date type data with particular global GMT UST time. So this will be automatically taken up by the database. We do not have to handle it from our end. So this will be the to-do schema. Now another important thing is that created by. This created by will be hidden by the user because it will actually contain the user ID of a particular user who is creating a particular to-do. Right? So to-do schema will be this much only. It will have a to-do ID which will distinguish the to-do from another list of to-dos, and to-do title, to-do description, deadline if it is necessary. If not, then not necessary. This will be an optional parameter, and created by, which will have the user ID of a particular user. The next thing which we'll design is the user schema. So the user schema, at some point of time you will find it very common in every application. So it will be having the user ID which will differentiate the user from another user. It will be an object ID. Now obviously when you authenticate the user, you always take a password. So I forgot to mention password over here in the customer address. Since you will log in the customer, so you also need to have a customer password also. This will be of string type as well, but you need to do hashing in this case. So we will learn what is hashing when we write the controllers for the applications. So let's shift this a bit upwards. Yeah. So let's come back to the user schema of the to-do list application. So user ID, user name if it is necessary. In some to-do application they directly do it with email, or they use Google authentication, so they will fetch the username from that place. So let's write here username as name, which is of string type. Okay, next the user email, which will separate the user, and with this email you can log in the user. So user name, email, it will be of string type. Next, his collection of to-dos, about the number of to-dos he has created. So to-dos, okay, and this will be an array obviously because he can create multiple to-dos, and inside this array we will have a object, and this object will have the object ID type of the to-do ID, which will differentiate his to-do from one another. Okay, so I hope we missed the password. Yes, so user password, and this will be of string type. Right? So this way you actually design the schema of the user in the to-do list application. So we will code this actually not now, in the upcoming videos where we will directly make the to-do list app in the upcoming videos. So you can expand this to atrocities, I have told earlier, because it's not possible to limit the database up to this much. You may have you may need to provide some more functionality to your to-do list application. So accordingly, you may need to expand your schema. So that's all about database design. This is a very important part of the database schema management. This is actually the work of the database engineers, but you need to have since you are a backend developer. So with that all, I would like to end this video. I will give you an assignment to design the database schema for a library management software, which will also teach you many things when you design. So try it out, otherwise mention in the comments and I will surely come up with a database design of a library management application. That's all in the video. I will see you in the next video where we will directly set up our environment for starting our backend development of the to-do list application, and we will learn a lot of things about how to code this user schema in our code itself in the project. So with that's all, I will end this video and I will see you in the next video. Till then, keep learning and keep exploring.